Hi everybody, welcome to Shel lectures. So here we'll be dealing with lyophilic and lyophobic salts. So the colloidal solutions in which the dispersed phase has some affinity for the dispersion medium, that is lyophilic, that is solvent loving. Okay, solvent loving. Lyo is solvent, philic is loving. So solvent loving, the dispersed phase must love the dispersion medium or the solvent. Then such colloids are termed to be lyophilic salts. And the examples are dispersing gelatin, starch, gum and proteins in water. So these all have a good affinity for water. Gelatin, starch, gum and proteins. And the colloids in which the dispersed phase has no affinity towards the dispersion medium, it's known as lyophobic salts, that is solvent hating salts. Example, metals and their sulfides. So here we have a good comparison of lyophobic salt and lyophilic salt. So lyophobic salt is actually a suspensoid and lyophilic salt is actually an emulsoid. So how can be prepared? Lyophilic salt cannot be prepared easily. Lyophobic cannot be prepared easily. There are a lot of complicated methods which have to be done to prepare lyophobic salt, which we will be discussing in the next forthcoming slides. Whereas lyophilic can easily be prepared by shaking the substance with solvent, because they are lyophilic, that is they are solvent loving. So easily they can be prepared. Stability, lyophobic is less stable, lyophilic is more stable. Reversibility, lyophobic irreversible, whereas lyophilic is reversible. Viscosity, lyophobic viscosity is same to the solvent, and here viscosity is greater than the solvent. For lyophilic, the viscosity will be greater than the solvent. Surface tension, lyophobic same thing, it's similar to solvent, and lyophilic, the surface tension is lower. Okay. Hydration, they are less solvated as they have less affinity for the solvent. Okay, that is they are less hydrated, that is they don't have good affinity for the solvent, right? So they are less solvated, whereas they are highly solvated because they have a good affinity towards the solvent. And then we have charge. These particles carry a positive or negative charge. Lyophobic and lyophilic do not have charge at all. Visibility, lyophobic can be seen under microscope, lyophilic cannot be seen under microscope. Coagulation, lyophobic can be precipitated by low concentration of electrolytes, but lyophilic requires high concentration of electrolytes for precipitation. Tyndall effect, lyophobic undergoes more scattering and lyophilic undergoes less scattering. Migration in electric field, lyophobic salt goes towards anode and cathode as these particles are charged, whereas here they may not migrate because they do not carry charge. General example, lyophobic mostly of inorganic nature and lyophilic mostly of organic nature. Okay, so here the terms which we would not know, solvation charge, coagulation or precipitation. Tyndall effect is the phenomenon by which the colloidal particles scatter light. So based on the type of the dispersed phase, there are three kinds of colloidal solutions. They are multimolecular, macromolecular and associated colloids. Multimolecular are nothing but multimolecular, so aggregation of large number of small molecules. Okay, and the example is gold and sulfur salt. Okay, gold salt and sulfur salt are example for multimolecular salts. And macromolecular salts are nothing but the size is larger, that is the size is of colloidal range. Example, starch, cellulose and protein. Associated colloids are nothing but at low concentration they behave just like weak electrolytes, but at high concentration they just behave as colloids. Okay, they just get associated at micelles and they become colloids, and this is what soaps, detergents all are based on. So micelles, as you can see the image here, there is a long chain which is pointing towards the center, that is the hydrocarbon chain, that is the CH2 part of all the associated colloids. So that is hydrophobic tail, because it's insoluble in water, it's hydrophobic. So it consists of the hydrocarbons, and the head which is present towards the water, towards which faces the aqueous medium, is the hydrophilic head, that is it's soluble in water. It's the polar head which is actually COONA. Okay, COONA, and this is the hydrocarbon part. So micelles, the CMC, that is nothing but the concentration for above which micelles are formed as termed as CMC, and for soap it is 10 power minus 4 to 10 power minus 3 mole liter per minus 1. So this much concentration must be there for micelles to be formed. And Kraft temperature is nothing but temperature above which the missiles will be formed. So Kraft temperature is the temperature above which missiles will be formed, and CMC is the concentration above which missiles will be formed. And then we have sodium stearate as example for associated colloids, which has the formula C17H35COONA, and sodium oleate has the formula C17H33COONA. And sodium lauryl sulfate has the formula CH3CH2 11 times SO3 minus Na plus. And then we have two more associated colloids like cetyl trimethyl ammonium bromide and P-dodecyl benzene sulfonate. Okay. So now we have to know about surfactants. That is, surfactants are nothing but the substances which are adsorbed at the interfaces like air-water interface, oil-water interface and solid-water interface. So the substances which are adsorbed at the interfaces are known as surfactants. So they are very essential for, they are responsible for micellation, that is the formation of micelles, and emulsification, that is a breakdown of fats. So there are three kinds of surfactants which are cationic, anionic and non-ionic. So this is based on the ionization. When ionized, these cationic surfactants give rise to cations, and anionic surfactants give rise to anions, and non-ionic do not ionize at all. So the examples for cationic, cetyl pyridinium chloride, and for anionic, sodium palmitate, sodium oleate, and the associated colloids which are of the formula CnH2n plus 1 SO3n. And then we have non-ionic, which has the example high molecular mass alcohol plus several molecules of ethylene. Okay, so these are the examples for cationic, anionic and non-ionic surfactants. So how does soaps undergo the cleaning action? That is, I told you that the hydrophobic part will be inside, that is facing towards the center, and hydrophilic will be pointing towards our aqueous medium. So soap actually helps in emulsification and it washes away all the oils and fats. And the negatively charged hydrophilic balls which are around, as we saw in this figure, the negatively charged hydrophilic balls around this, actually what do? They prevent them from forming aggregates. So they should not form aggregates, right? So they prevent them from forming aggregates, and this helps in the cleansing action of the soap. So here we are going to see the methods of preparation of lyophilic salts. So lyophobic salts in detail. Lyophilic salts can simply be prepared by warming the solute with solvent, whereas lyophobic have there are two methods of preparing lyophobic salts. They are dispersion methods and condensation methods. Dispersion methods, larger particles are broken down to smaller ones, and condensation, single molecules are aggregated to form colloidal particles. That is, single molecules are aggregated to form colloidal sized particles. So the first dispersion method, that is larger to smaller, is mechanical dispersion. So here the substance which has to be dispersed, we are grinding it and we are just shaking it with the dispersion medium, but it does not form a solution because it's not a lyophilic salt. So we are just taking that substance and forming a suspension, and that suspension is passed through a colloidal mill where they are broken down to produce particles of colloid size. Okay, so here it's ink and paints. The examples are ink and paints. And then here we have Bredig's arc method. Here you can see metal electrodes with an arc which is immersed in a solution containing water and potassium hydroxide, and there are also ice cubes around that to actually cool the solution. And what happens is, due to the much heat which is produced in the arc, the metal just melts and condenses to produce a salt. And this is used in the preparation of colloids like gold, silver and platinum. So all these can be prepared by Bredig's arc. So these two are methods of dispersion method. Dispersion method is nothing but larger particles are broken down to colloidal size. Okay, so about condensation method we will be dealing with in the next video. Subscribe to my channel if you have not done so far. Like and share this video to whomever you know. Thank you so much for watching.